All right, in this section, I will derive implicitly. I will find the slope of the tangent line of a graph. Then I will find the tangent line when given the explicit formula and a given point. Then finally, I will find the second derivative implicitly. So yes, what is implicit differentiation? So implicit differentiation is the procedure of differentiating an implicit equation with respect to the desired variable, while treating the other variable as an unspecified function of. Okay, so when would you use implicit differentiation? Usually when your equation has more than one letter or different letters, right? So an example would be like x squared y plus xy squared equals 3x. That's perfect. That is the perfect example of what, when you could use implicit. So now that you know when to use it, how do you use it? So the steps for implicit differentiation is, step one is differentiate both sides with respect to x. So when you differentiate a y term, multiply dy dx. And I'll explain that when we do an example. And then step two says solve for dy dx. So it's just pretty much two steps. Okay, so let's start with example one. It says find dy dx. Basically, dy dx means derivative in respect to x, right? Implicitly for the equation. Okay, so what we're going to do is take the derivative of each term in respect to x. So let's start with 4x. What is 4x in respect to x? It's going to just take the derivative usual. So the derivative of 4x is just 4. And then in respect to x, it's going to be dx over dx. Now, some people don't have, will just put nothing. They'll just put just 4. That's perfectly fine because dx over dx is the same thing as 1, right? What's the derivative of negative y cubed? So it's going to be negative 3y squared. And in respect to x, it's good. Then what you're going to do is take on, you're going to add a dy dx, right? Because we have a y term and we're trying to take the derivative in respect to x. Okay, so this term is negative 3y squared dy dx. Okay, what's the derivative of 12y? Well, the derivative of 12y is just 12. In respect to x, it would be dy over dx equals, and then the derivative of 0 is a constant, which is still 0. Okay, now what you would do is, because you want to, your goal is to solve for dy dx, get anything that doesn't have a dy dx, move it on the other side, anything that has a dy dx, collect it on one side. So this 4 dx, or basically this 1, it doesn't have a dy dx, you're going to subtract 4 from both sides. And that's it, because this one has a dy dx and this one has a dy dx. So our equation on the left side is going to be negative 3y squared dy over dx plus 12 dy over dx equals to negative 4. Okay, then what you want to do is solve for dy dx. So I would factor out a dy dx. So this would be dy over dx. And then this would be negative 3y squared plus 12. And then this is going to be negative 4. Next step is solve for dy dx by getting rid of this. So you're going to divide negative 3y squared plus 12. Negative 3y squared plus 12. So your final answer is going to be dy over dx equals to negative 4 over negative 3y squared plus 12. Okay, so that is your final answer. Move on to example 2. So example 2 says find dy dx by implicit differentiation. So this one's a little bit more work because we we'll have to take the product rule. So let's start with x cubed. The derivative of that would be 3x squared dx over dx. Or you could just say 3x squared because this just becomes 1, right? Now this whole thing is one thing. So how do you take the derivative of that? Well, you will have to use the product rule, but I noticed that negative 3 is a constant, so you can just take it out. It makes it easier. And then from here, just take the product rule, right? So the same thing with this one right here. You get this 2 is a constant, so you could take it out. So it'd be 2xy squared equals to the derivative of 12 or a constant 0. Okay, so let's take the derivative of this thing here. So we are going to use product rule. So my f is x squared, and then my f prime would be 2x in respect to x would be dx over dx, or just 2x. And then my g is y, and then g prime in respect to x would be 1 dy over dx. Okay, so what is, if you recall, the product rule is f prime plus g prime. So here, let me product rule is f prime of g plus g prime of f. So yeah, f prime of g, so it's going to be -3 bracket, and then f prime is just 2x, right? The dx cancels. And then g is just y plus g prime, which is 1 dy over dx times regular f, which is x squared. So when you FOIL that out, this is going to be minus 6xy minus 3x squared dy over dx, right? And then you have this 3x squared dx, or just 3x squared, right? Okay, now let's take the derivative of this thing. So same thing, product rule, f is x. The derivative in respect to x would be 1 dx over dx, or just practically 1. G is a y squared, so g prime would be 2y dy dx. So it's going to be plus 2 product rule f prime, which is 1 g f prime, and then g is y squared, plus g prime, which is 2y dy dx, and then regular f is just x. So this would be y squared plus 2xy dy dx. So this is going to be plus 2y squared plus 4xy dy dx. And then this all equals, on the right side, it just equals 0. Okay. What I'm going to do is get anything with the dy dx on one side, and anything that doesn't have one, move it to the right. So first off, could we collect like terms? No, we can't. So I'm going to move this 3x to the right, and move this 2y squared to the right as well, and add this 6xy to the right. So you're going to add 6xy minus 3x squared minus 2y squared. So now you're left with negative 3x squared dy over dx plus 4xy dy over dx equals to 6xy minus 3x squared minus 2y squared. Then factor out a dy dx on the left side. So let's do that. So factor out a dy dx, and you get negative 3x squared plus 4xy bracket equals to 6xy minus 3x squared minus 2y squared. Then just solve for dy dx by getting rid of this thing. So your final answer is dy over dx equals to 6xy minus 3x squared minus 2y squared all over negative 3x squared plus 4xy. That would be your final answer. Yeah, so this is 6x. Yeah, that's your final answer. So yeah, that was a little bit a longer one because you did have to use the product rule and take the derivative of each term of in respect to x. Okay, example 3. Find the slope of the tangent line to the graph of x squared plus 5y squared, 4y squared equals 4 at the point of radical 2, comma, negative 1 over radical 2. So basically you're finding slope m, right? So the first thing is you got to find the derivative in respect to x. So we're going to implicit differentiation. So the derivative of x squared in respect to x would be 2x dx over dx. The derivative of 4y squared in respect to x would be 8y dy over dx. The derivative of 4 or a constant is 0. Okay. Then on the left side, they both have a dy. Oh, this cancels. So anything that doesn't have a dy dx, move it on the other side. So I'm going to move this 2x to the right by subtracting 2x. I get 8y dy over dx equals to negative 2x. Solve for dy dx, so we have to get rid of this 8y by dividing both sides by 8y. So you get dy over dx equals to negative 2x over 8y. Get rid of this. This both could be reduced by 2, so this would be negative x over 4y. So dy dx equals to negative x over 4y. Now we want to find a slope. So slope is a number. So they give us a point of radical 2, comma, negative 1 over radical 2, right? So let's plug in that point into this equation. So do dy dx of radical 2, comma, negative 1 over radical 2. So that would be negative, and then x is radical 2. And then my y is going to be 4, and then y is, replace y with negative 1 over radical 2. So it becomes negative radical 2. And then 4 times negative 1/2, negative 1 over radical 2 is negative 4 over radical 2. And when you clean that up, you should get 1/2. So yeah, the slope at that point is equal to 1/2. Okay, so let's do example 4. Find the tangent to the line of that graph and at the point of radical 2 over 2. So what you're doing is like in example 4, what we're going to do is find the slope, and then we're going to find the equation. So you're going to use point slope form, and then that'll be your final answer. Okay, so let's do that. So what would I do first? I think I should FOIL off the x squared. So yeah, let's do that. So FOIL it out. So this would be x4 x squared y squared equals to y squared. X fourth x squared y squared. Now let's just take the derivative implicitly. So the derivative for x to the fourth is 4x to the 3 dx over dx. The derivative of x squared and y squared. Okay, so product rule, right? And my f is x squared. F prime is 2x dx over dx. G is y squared. G prime is 2y dy in respect to x. So this would be 2y dy dx. Product rule is f prime of g plus g prime of f. So, okay. So f prime is 2x. Dx over dx just becomes 1, so it's just 2x. And then regular g is y squared plus g prime, which is 2y dy dx. And then regular f is just x squared. And then equals to the derivative of y squared in respect to x would be 2y dy dx. This is going to be 4x cubed. And then dx over dx is just 1, right? So when we clean this up, this is going to be 4x cubed plus 2x y squared plus 2x squared y dy over dx equals to 2y dy over dx. Then anything with the dy dx get on one side, anything that doesn't, move it on the other. So this 2y dy dx, let's move it to the left because subtract 2y dy. And then what you're going to do is subtract 4x cubed and subtract 2x y squared. Okay. Cancels, and then this is going to be 2x squared y dy dx minus 2y dy over dx equals to negative 4x cubed minus 2xy squared. And then over here on the left side, factor out a dy dx. So this is 2x squared y minus 2y. This is negative 4x cubed minus 2xy squared. Get rid of this, so this is 2x squared y minus 2y, 2x squared y minus 2y. You get dy dx equals to negative 4x cubed minus 2xy squared over 2x squared y minus 2y. So what we got to do is find slope. So that's why that point they give us comes in handy. So we're going to plug in, we're going to use the point. Oops. We're going to use the point radical 2 over 2, comma radical 2 over 2, right? So let's do that. Dy dx of radical 2 over 2, comma radical 2 over 2. So this is negative 4, and then anything with an x, just replace it with, okay, so this is your x, this is your y, so this is going to be radical 2 cubed minus 2, and then x is 2 over 2, and then y is also radical 2 over 2 squared, all over 2, and then x is radical 2 over 2 squared, y is radical 2 over 2 minus 2, and then y is radical 2 over 2. Okay. So believe it or not, when we do all the work, it'll somehow become 3. So this is your slope, right? M equals 3. So now what you're going to do is use point slope form because they want an equation. So point slope form is y minus y1 equals to m times x minus x1, right? So it's going to be y, and our y1 is actually the point we used, which is this one, right? Radical 2 over 2. And m is 3. And then this is going to be x minus x, which is radical 2 over 2. So when you FOIL that out, that'd be 3x minus 3 radical 2 over 2. Solve for y by adding radical 2 over 2. And then what you're going to do is when you solve for it, you're going to get y equals 2. It eventually become y equals 3x minus radical 2. So what on earth does that linear line represent? So if we were to graph the original graph, I mean the original problem, right? It would look something like this, roughly. Do the vertical line. And then it's going to look something like this. Okay, so with this equation here, y equals 3x minus radical 2 at the point of radical 2 over 2, radical 2 over 2. So where is radical 2 over 2? It's about right here. So that point would be right about here. And then if you graph that, it forms a tangent line like this. So this is going to be, this line here is going to be y equals 3x minus radical 2. So that's, yeah, that was a lot of work, but you found the equation. Okay, and then I think the last one, find the second derivative implicitly. So it's pretty much like taking the second derivative, but this time we're going to do a little bit of substitution. So first, let's find first derivative in respect to x. So derivative of x squared would be 2x dx over dx. The derivative of y squared in respect to x would be 2y dy over dx. The derivative of constant is 0. So this cancels, so you're just left with 2x plus 2y dy over dx. Subtract 2x. We get 2y equal 2y dy dx equal to negative 2x. Divide this by 2y, and I get dy over dx. And the 2's cancels, you're left with negative x over y. And what's next? We got to find the second derivative. So this is our first one. This will come in handy. So I'm gonna box it. This is not our answer, but I'm gonna box it because we might have to substitute that. So how do you take the derivative of negative x over y in respect to x? Because we're taking it again. So you're definitely gonna use quotient rule, right? So my f is negative x. So f prime would be negative 1 dx over dx, or you could just say negative 1. And then g is y. G prime would be 1 dy over dx. Okay, so now let's apply the quotient rule. So the quotient rule is f prime of g minus g prime of f all over g squared, right? Okay, so this is going to be f prime, which is negative 1, times g, which is y, minus bracket g prime, which is 1 dy over dx, times it by negative x, bracket all over y squared. Okay, so that would be this would be negative y plus x dy over dx, and all over y squared. Okay, so what we're going to do is substitute dy dx with negative x over y. So that's going to be negative y plus x, and then dy dx is negative x over y over y squared. So that would be negative y minus x squared over y over 1 all over y squared. So we have a complex fraction, right? So let's simplify the numerator. So this needs a y, so this needs a y, so that'd be negative y squared. So it's like saying negative y squared minus x squared all over y squared. And I guess over here you could factor out a minus 1, right? So it's like saying minus 1 y squared plus x squared all over y squared. So if you do the bracket method, it would be, you have a 1 here, a y there, so the common denominator would be y. So that would be negative y squared plus x squared over y cubed. And then finally, what you could do, so your final answer would be d squared y over dx squared equals to negative. And then what you could do is replace y squared plus x squared with 25, because that's what they said, x squared plus y squared equals 25. So this would be 25 over y cubed. So your final answer is going to be negative 25 over y cubed. So that was implicit differentiation. So that wraps it up for today. Thank you. Bye-bye.